Okay, let us start our session with Al-Fatiha first. Okay, let us continue with the direct method that we have learned this week. Yeah, so we learn how to draw the shear force and bending moment diagram by direct method or the area under the graph. Okay, so last time we learned how to draw it with the point load. Now let us look at distributed load and a point moment. There is a point load, there is a point moment, and then there is a distributed load. How do we draw the graph? Okay, how do we show it? Okay. So let us review back the simplest one here. Okay. So this is 100 Newton, and then we have a 300 Newton there. Yeah, this 2 meter, 2 meter there. Yeah. So I have a choice because this is already on the left here. Yeah, this is already on the left there. I have a choice. I want to start from the left or to the right. If I want to start from the right, then I have to find all the reaction there. Now I want to start from the left. I don't have to find the reaction, but I can find the reaction later on by doing the graph. Okay, let's do that one. See that? So start from A to B and B to C there. A, B there, C there. I want to draw my V. I start from 0. I start from 0 there, positive, negative there. So as I move along here, point A, C, go down by 100. So go down 100, go down 100. So from 0, I go to minus 100. That's meaning you go down 100. So the value must be minus 100. So when I move to the right here, what is the terminology that I use? Who still can recall yesterday? What did I say? When I move to the right here, what do I do? Please, what did I say yesterday? Hello?
Constant.
It's not constant yet. Yes, it's constant. But the terminology that I use, what do I use yesterday? See that? You miss all the main point that I teach. That's the problem with you guys. Something come in from your ears and gone. You don't do the recalling. Okay? I use the terminology maintain. So I go to here, I still there is no instruction go up or go down. So what do? I maintain the value of minus 100. That's why it's constant. I maintain until at some point there is instruction to go up by 300. Go up by 300, so there must be up until there must be positive 200 there. So the changing is 200. And I move from B to C there, I maintain the value 300 there. So when I move here, so the thing must be go to here. So that means here there must be a reaction forces of 200 there to go down. So I know the reaction from there. Are you with me, guys?
Yes, doctor.
That's how you draw the V graph. So what about the M graph? I mark this one area 1, this area 2. I mark that and I write here. What is area 1? Area 1 is minus 100 times 2. The value is minus 200 meter. Area 2 is equal to positive then. So 200 times 2 is equal to 400 meter. So I want to start from 1 point there. So from point 1 there, start from 0. I want to go to point B. So this is going down, it's going up. This is negative. So point 2, how do I get point 1 is equal to 0? Point 2 is equal to 0 plus the change in area. So the change in area is what? 0 minus 200. So the value is minus 200. So minus 200 is there. There. So this is minus 200. So go down by the value of that 200. And then when I go to the point C there, from B to C, I want to go to, this is point 1, this is point 2. I want to go to point 3. You must start at the value minus 200 and plus the change in area. So now you start with minus 200. The change in area is 400. So the total now is 200. So you must go to positive 200 there. So this is point 3. So this is positive 200. So there must be go to 0, right? So there must be a reaction. There must be a reaction. The value is 200 positive. Positive means in what direction? Not positive, going down. So that one the other way around. This must be the value of 200 meter. So this is why going down there. Negative 200, that's why going down to 0. Start from 0, finish to 0. So to show that. So point 4 is 3. The value is point 3. Point 3 is plus 200. And the change in plus the change in moment. Change in moment, we have a 200 there. So plus 200 minus 200 is equal to 0. So these are all the working to show that how you show the graph there. And this is from yesterday. From point load only, how we can. So place area, you show the working there. So you move from here to here, that's going down. Why straight line? Because this is square area. And then from here to here, it's going up. Why? Because it's straight line also, because square area. Then the value 1 there, you show the value, how you got the point 2. Point 2 is the initial value changing with that one. You got the changing there. You got the final value. How you got the point 3 there. The initial value is point 2. Go to the changing in area, that one. You got the value. How you got the point 4 there. From point 3 go to point 4, that one. The changing, got that one. Are you with me, guys? These are all the working must be shown. Okay? So now let us this is yesterday. Now let's go to the distributed load and a point moment. So how do we do the graph? Yeah? Yeah? So what? Okay, let us look this one. Yeah? I have a distributed load there. Yeah? I have a distributed load. And then I have from here, I have a moment. This omega is 2 meter there. From A to B. Omega is equal to 100 Newton per meter. So 2 meter there. So there's a moment of 300 Newton meter at B. And there is a force going down there. This is 100 Newton. So how do I draw the shear force and bending moment from left to right? Okay, are you with me, guys? So I don't have to find the reaction because I want to start from the left. If I want to find the reaction, it's okay. No problem. So what do I do here? I want to plot the graph of V. There's a V there. Yeah? I want to plot the graph V there. So what do I do here? At point A there, this is 2 meter there. So 2 meter. Point A there. So this is asking us to go down. How much going down there? From A to B, it's not a straight line go down. It's continually. From A to B, you go down a little bit, and the total is 100 times 2, 200. So there must be a constant line there, straight line there, until point B, from 0 until minus 200 there. How you get minus 200? You start at 0, you go down by 200. So you're from 0, you go down 200. But it's not a constant jump. It's continually go down. This is how the area, that one is being counted. Okay, go down there until point B here. So that is minus 200, the value. And then from here to here, I don't have any force. This is a moment. So this is not a graph force. So what do I do here? I maintain. Remember the terminology. Maintain as I move from here to here, I maintain what I have value now. The value is minus 200. I maintain that 200. Minus. And then ask to go down 100. So this must be minus 300 here. Okay? So this must be minus 300. Because from 200 and go another one down, minus 10. And then I go here, maintain. Up until the end. This is the end. Now I know. This must be, the moment must be positive clockwise 300. Why? Because this must have go back to 0. Sorry, not this one. The force. The V must be 300 go down there, go up. Because this the V here, so the V must ask us to go back to 0. Start from 0, finish at 0. So I know that the wall have a reaction go up. From the graph, I can find the reaction there. Even though at the beginning it's just a fixed point. And then the moment I find from the moment graph. Okay, let's look at the moment now. If I want to draw the moment diagram, see that? I have to draw the area. I have to calculate the area. How many area we have here? This one. Area 1. This triangle. And then area 2. Another triangle. And then this one is area 3. So all are negative. All are negative. Okay? All are negative. So I'm going down. 0 there. So show your calculation first. Show your calculation first. Your A1 is equal to, this is 200, this is 2. So this is triangle, half. Half of 200 times 2. So the 200 is minus. So the area is what? Half of 200 times 2. This is negative 200 meter. You go down by 200. And then what is area 2? 200 times 2 also by square. So 200, negative 200 times 2 is equal to negative 400 meter. Then A3 is also a square. Negative 300 times 2 is equal to minus 600 meter. So all are going down. All are going down. So, but remember, beside this, I have this one, 300 clockwise, up. Yeah, the 300 is moment here, effect on the moment graph at point B. So what do I do there? I start at there. Can you see the graph there? Okay, go down. Those are the value there. See that? Start at 0 here. I go down by 200. At point B here, I must go down to 200 there. This is minus 200. So it's not a straight line. Because this is a triangle. The initial one is less, the second area, the first area is less, the second area here, first and second here bring the two position, second is more. So the graph is going down like that. So the changing is less at the beginning and more at the end. The graph is like that. Half here, the changing is very small. The second half here, the changing is very high. So the changing is area here very small. Small, high. So small, high. That's how you understand the graph then. So the value is still 200 there. And then, that one is straight line then. Straight line, 400. So straight line, 400 becomes 600. So there might be 600 there. Straight line. This might be minus 600. So the changing is 400, 200 until 600 is 600. Straight line. Because why? Square area. And then there's another, sorry. Before I do that changing, I forgot. Before I go that area, I have bring up or 300. So jump there from minus 200 until positive 100. So this must be positive 100. So there's a moment positive there. Jump. The sign convention say clockwise, go up. Clockwise here, the graph must go up. Sign convention means the whole world is choosing that sign convention. Clockwise, go up. Okay? So 100 there, intermittent. And then this one go down straight line to 400. So you must go down to straight line to minus 300. Why? Because positive 100 go down by 400, so must be at minus 300. At minus 300, you go down some more for 600. So there must be another go down there. Another go down there. Yeah? And then another go down there. A different slope. This slope is different from that slope. This slope is much steeper because this is from 300 until 900. And then you go up there. You go up mean clockwise. So that means here there must be another 900 moment clockwise. That's why you go up to 0. Those are the reaction. Because you finish at minus 300 cannot be there. You must finish at 0. So the wall must have that reaction. That one. So this is the graph of the shear load and the moment. Curve here, straight here, straight here, straight here, straight here. You see that? Are you with me, guys?
Yes.
This is the how you draw. See that the area? Why this one is area here? So this one is going down because the force is going down. And then the area here, changing of the moment here. The area in the load, changing in the area in the FBD, changing in the shear force. The area in the shear force, changing in the moment. The point load here, changing in the jump in the shear force. A point moment there, there's a jump in the moment graph. Point load, jump in the shear load. Point moment, there's jump in the moment graph. Those are critical points. How you do those calculation. Show the working there. And then, this I done it in your head. You cannot do this. Show your work there. Point 1 there. Point 1 is 0. Point 2 there. Point 3. Point 4. Point 5. Point 6. So how do you do that? Point 2 must equal to 0 plus change in area. So what do you have there? 0. Change in area is minus 200 is equal to minus 200. Show that one. And point 3. How do you get point 3? Point 2 plus minus 200 plus the moment there 300 is equal to
100.
this is what? Change in moment. So you have a plus 100. And then how do you get point 4 there? And point 3 is plus 100. And then plus changing in area. So how do you get that? Minus plus 100 minus 400. So you got minus 300. Show that this is minus 300. And point 5 there. Start at point minus 300 plus change in area. So what do we got there? Minus 300 minus 600 is equal to minus 900. And so on. So show all the working there. Are you with me, guys?
Yes.
Okay. So somebody please snap this picture first. Let's snap this picture. Okay. Show you another example.
Oh gosh, okay, so we're all in here. The challenge officially has begun. We are in the pool of orange slime. I don't know what this is. You look good. Thank you. Wow. Safety first. I usually do. You have another one, Doug? I kind of like that. Whoa!
Carter, what else is in that box?
Right. Okay, guys. Now that we are all completely inside
Okay.
the slime, I think it's time to
So
start
these are the
challenge. And the way the
simple
challenge
case like that.
here on my channel is
There's a point moment at point A, B, C, D. So we have AB one section, BC one section, CD one section. There's a point moment there at point C. There's a point load there at point B. And between B and C there is distributed load. Yeah? Those are the loading there. So for this case, I must find the reaction first. Simple reaction. The first step is a must. What is my reaction A? What is my reaction B? Yeah? So to do that, I have to draw this one. What are the different color of centroid here? What are the load there? So the load here must be 300 times 2. Yeah? There's a load there. 300 times 2. But that is different color. I don't do the same color. Confuse me with the point load. This is not a point load. This is just to show the centroid. Total force is pushing down there at the centroid. So the distance is half of 211 there. So I want to find the value there. The best thing is what to do. The summation force in Y. Summation force in Y is equal to 0. What do we have there? RE plus RD going up, down, minus 200. This is minus 3 times 2, 600. This is not force. This moment. No, it's equal to 0. So RE plus RD is equal to 800. So put it aside. And then moment, summation of moment. You can choose any point. You use the same thing, free body diagram over and over again. You must start with free body diagram. Any problem, any diagram, any question in engineering.
You ready?
In engineering, That's why we are doing the free body diagram, Okay? At point A there, it's equal to 0, static. What do I get? 200 times 1. 200 times 1, clockwise. What about that 300 times 2 there? The distance is 1 here and 1 there. So, plus also. So the load is 300 times 2, 600. The load is 300. The distance is 2 from here to here, 2. And then plus another 200 there. And then minus RD time 1, 1, 2, 4. Equal to 0. So what is RD there? So this is 200, 200, 400, 1,000, 200, 600 times 2. Plus 400, 1,600. So 1,600 divided by 4 is equal to 400 Newton. So here is 400 Newton. 400 Newton. Put 400 Newton here. So your A is also 400 Newton. You got that one? Okay. This work has to be shown. Yeah? And then I'm doing the graph. Below the one must show the graph. Okay? How do I do that? V graph direct method. The V graph there. See that? I go from A to B to C to D. I start from 0 there. 0 up 400. So I go up 400. Up 400. So this must be positive 400. And I move from here to here, maintain. Use my wording, maintain the current value that you have. Now you are at 400, you maintain at 400. Up until here, before you go to the distributed load, there's a point load going down, 200. So from 400, go down, jump, 200. So must be at 200 then. Jump 200 down, so you stay at positive 200 now. And then, as you move from here to here, this red is not there anymore. And then, as you move from here to here, how much going down? 300 times 2, 600. You must go down 600 from positive 200. Straight line or curve? Wait first. The amount must be 600 go down. So you must meet at minus 400 then. So the question is, how you move from 200 to 400 here? Is it a straight line? Is it a curved line like that or curved line like that? So you take it like that. So this is a square area. So the changing is constant. So the changing constant, the line must have a constant slope. But the total must be 600 from positive 200 to negative 400. And then from here to here, there is a jump in moment. Sorry, not moment. This is V. So what do we do? There is no force there. You maintain as 400. Up until here, there is a 400 up. You go back to 0. 0 here. See that? Maintain here, you jump there, and then you slowly going down there, and then you maintain there, and then you up. So this is the graph of the V. Are you with me, guys?
Yes.
Now I want to plot the graph of moment. What do I do? I must know the area. See that? How many area do I have? The area 1 now. Now I have this simple small triangle there, A2 there. And then this one is A3 there. This is A4 there. So I have to decide. From here to here is 2 meters. But this is very small here. And then this is, the angle must be the same. The height is 200. The height is 400 there. So this must be A. So this must be 2 minus A. 400 here. So I have to solve the A first because I have to calculate the area 2 there. See that? So I have to calculate that A first. How do I get my A there? A divided by 200. A divided by 200 or 200 divided by A. So 200 divided by A. Same with 400 divided by 2 minus A. Same is 400 divided by 2 minus A. I don't have to put minus 200 because it's just a triangle. Okay? This is solving trigonometry. So what do we have there? This one times this one, we have a 400 minus 200A is equal to 400A. So 400 is equal to 600A. So my A is equal to 4 over 6 is equal to, what's the value there? Please, 2 over 3, 0.66. So this is 0.66. So this must be 1.33. 1.33, 0.66. The length of that one. So we solve that one by simple mathematics. Okay? And then I want to find the area. Area 1, area 2, 3, 4. 1 is positive. 2 is positive. Triangle. 3 is negative. Triangle. 4 is negative. It's not triangle, square. So what is area 1? 400 times 1.
1.
So positive 400 meter. What is area 2? Triangle there.
Separuh.
The height is 200.
2.
Time the length here is 0.66 and time half. So the value is still positive. So what's the value there, please? Push your calculator.
66.
Huh?
66.
66.6 meter. Yeah? Positive. So A3 now is negative. Area is below the graph. So what do we have there? So half of height is 400 and minus there, and then 1.33. So what is the value there? The value must be minus. What is the value there, please?
Negative 266.
266. Okay? Negative. And then A4 minus 400 and time the area is 1 there. So negative 400 meter. Very clear there. Now you want to plot the graph. Look carefully. Yeah, look carefully. This is the from A to B, the area is positive 400. So the line is, the area is square. So the line must be straight line. So from 0 here, you move to 400. This is 400. This is positive 400. And then you go up some more because this is area is positive 66. So go to 466 then. It's not a straight line anymore because the first one is curved line because this is triangle. Curved line there. Yeah? So the value is 466.6. And then you go down by that much. From 466 you go down by that much. How much that one? A3 here. 266. From 466 you go down to 266. But this one is not a straight line because this is triangle. The first area is smaller area, the second area is bigger area. So the graph must be, you go until positive 200. That's how the graph like that. Yeah? This must be positive 200. How is that positive 200? Then this 0.1, 0.2, 0.3, 0.4. So how you get 0.1 is 0. How you get 0.2? 0 plus change in area. So what is change in area you have? 0 plus 400 is equal to 400. Show the working there. How you get 0.3 there? So 400 plus change in area. So what we have there? 400 plus 66.6. You got 4, 66.6 there. And then 0.4 there. How you get the 0.4 there? The latest one is 466.6. You go down by that area. That area is minus 266.6. So the value must be 200. Positive 200. That's why you go to positive 200 there. And then how much you go down there? Sorry, before you go down there, there is a jump of 200 there. So the jump is going up or down? Clockwise, up. Go up some more to 400. So this 200 up, so you go to 400. So your 0.4 is there, 0.5 is there. How you get 0.5? The current one is positive 200 plus change in moment. So you got 200 plus 200 is equal to 400 now. And then from 5 here, you want to go to 0.6 here, the area is going down. How much going down? 400 going down. 400 going down to 400, you got no zero there. So 0.6 is 400 minus 400 is equal to 0. Are you with me, guys? Hello?
Yes, doctor.
Straight line. Cause it's square. Triangle there. It's not a straight line. Triangle there. It's not a straight line. But go down. Negative, 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 positive. This go up. Positive. Go down. Go down. And then there's a jump moment. It's jump there. And then there's a going to that one is the area is negative. Go down. So start at 0, finish at 0. Okay, guys? This is how you do your shear force and bending moment diagram by the cut section. And not the cut section. Cut section, you have equation. And here we don't have equation. We have the area and the point values. How you get the point values. Okay, I don't want to go a bit further. And we stop today. Maybe you have a test or whatever. And then continue. I'll give you homework and finish it on Friday, okay? Okay, your test is on
Saturday.
Saturday. I'll give you all the past year question on the link. That one, please do your revision. Okay? I think you have done a lot of exercise to understand the basic fundamental. So good luck for your test. Okay, Assalamualaikum.
Waalaikumsalam. Thank you, doctor.
Thank you, doctor.